Hello. Uh, so what we're going to do now is properties of logarithms, section 6-10. If you go to your packet and go to page 143 in your packet, you will see this page, and this is what we're going to talk about today. There are three basic rules, properties of exponents that we're going to talk about: the product quotient, the product property, the quotient property, and the power property. Okay. Before we do that, I'm going to ask you to go through each of these at the top. And this is just kind of an investigation. You're going to go through each of these with your calculator, and you're going to put your answers here to about 4 decimal places. And you're going to see, and you're going to compare some of these. And I want you to see if you can come to some conclusions or at least guesses on how these properties work. Okay? If we have time in class, we're going to do this in class. But if we haven't done this in class, then stop the video now and do this. Okay. I'm not going to do this with you. Just go ahead and do that. And then I'm going to start talking about this. All right. Okay. So now that you've done that, we're going to talk about these properties. And if you want, you can fill this in. I'm actually going to use more space to fill these in. So I'm going to do this on another page. We're going to talk about the product property, quotient property, and the power property. Okay. I need more space than this, so I'm just going to do this over here. First of all, we've got the product property. Okay. And what this is, it's the log of a product. Okay. When you take the log of a product, algebraically, this is what this looks like. When you have something like, let's say you've got the exponentiation property is something like 10 squared times 10 to the third equals 10 to the fifth. And in words, verbally, what that means is when multiplying two powers with the same base, okay, you leave the base alone and you add the exponents. Okay, see how there's not a ton of space in this little box to put all that in there. Okay, but we already know this property. This is just kind of a review of this property. Okay. So when you're multiplying two powers with the same base, we all know 10 to the second, 10 to the third is 10 to the fifth. We leave the base alone, we add the exponents. Okay. Now when we have the log of a product, so the log property, algebraically, it's going to look like this. Okay. When I have the log, so algebraically, the log of a product, so log base b of a product, like x times y, is equal to log base b of x plus log base b of y. Okay. And if we want to say that verbally, okay, I'm going to start with this side. I'm going to say when you add two logs with the same base, you can combine them into a single log where you multiply their two arguments together. Okay. So when adding two logs with the same base, you can, I'm going to use the word combine, or condense. You can condense them into a single log by multiplying the arguments together. I'm going to call them arguments or powers. Okay, and I'm going to explain that, what I mean by all that. I'm going to give you some examples. Okay. So let's use a couple examples here. Let's say I wanted to do log base 2 of 5x. Okay, so that's the log of a product 5 times x. I can break this down into log base 2 of 5 plus log base 2 of x. Okay, this is called expanding. Okay, I'm expanding this log, breaking it down as much as possible. Okay, basically, I'm going from left to right in this equation. Okay, now I can also go from right to left. I could say if I have something like log base 2 of 10 plus log base 2 of 3. Well, I can combine these two logs, condense these two logs into a single log, and say log, all right, log base 2, and then I multiply these two together of 30. Okay, this is called condensing. Okay, so if you go left to right, you're actually expanding. Right to left, you're condensing, but you're using the same rule. Okay, now I want to explain this in another way. So see how up here I said you're multiplying the arguments or the powers? Let's take this equation up here, and see how that gets turned into a log equation. Okay, so I'm going to write down 10 to the second times 10 to the third equals 10 to the fifth. Let's think about what we did here. When we multiplied these two arguments or powers together, we combine them into a single exponential expression by adding the two exponents. Okay, remember when we said one word for a log? A log is simply an exponent. Okay, so let's think about this. What this say? What we know what this means. This means 2 plus 3 is equal to 5. Okay, let's talk about what this is. The log of 100. Do we agree that's equal to 2? Notice I didn't put a base there. So the base is 10. 10 to the what gives me 100. Okay. Log of 100 is 2. And then plus 3 is really the log of 1,000. If we remember what a log means, the base here is 10. What's the exponent I put on a 10 to get 1,000? Well, that's 3. So this should be equal to log of 1, 2, 3, 4, 5. Log of 1, 2, 3, 4, 5. Log of 100,000. Okay, because 10 to the fifth is equal to 100,000. So basically what we've done here, this is log of 10 squared plus log of 10 cubed equals log of 10 to the fifth. When I add two logs together, I can combine them into a single log by multiplying the arguments or the powers. So basically what I've done, remember this, log of 10 squared, that's 2. Log of 10 cubed, that's 3. Log of 10 to the fifth, that's a 5 there, that's 5. Okay, these are the logs. The exponents are the logs. We added the logs together. Okay, the 2 plus the 3 is equal to 5. Log of 100 plus log of 1,000 equals log of 100,000. And so when we combine two logs together, the way that we do that is exactly that. We're using the this rule up here, the rule for exponents, but kind of twisted around, kind of in a different way. Well, in the same way, but looking at it from a different perspective. Okay, adding the exponents together. When do we add the exponents together? We add them together when we're multiplying the powers or the arguments. We add them together when we're multiplying the powers. Okay, powers or the arguments. Okay, so let's go to the next rule. I know this was a lot to fit in that little box. Let's go to the next one, which is the rule for a quotient. So now we're going to go to quotient. So quotient, and we've got the rule for The first box is for exponentiation. The second one is for logs. Okay, so algebraically, the rule for quotient is if I have, let's say a base raised to an exponent divided by a base raised to another exponent, that's the base to the x minus y. Okay, which means in words, verbally, what that means, when dividing powers with the same base, you leave the base alone and you subtract the exponents. Okay. Now, that same thing when we talk about logs is log of a quotient. Okay. So log of a quotient. So we can talk about this. This is really the log of a quotient. Okay. So when we take the log, base b of a quotient, let's call it m over n, we can break that apart. We can expand it into log base b of m minus log base b of n. Okay. So here we're expanding. When we go left to right, we're expanding. Right to left, we're condensing. Okay. So let's do this in words. Okay. And I'm going to start from the right to explain. I'm going to say when we subtract two logs with the same base. So when subtracting logs with the same base, you can condense them into a single log by dividing the arguments. We're dividing m and n, the arguments or the powers, by dividing the powers. Okay. Let's look at what this means. Let's say I'm taking something like 10 to the 5th and I'm dividing 10 to the 3rd. I'm dividing two powers. Okay. Well, that's 10 to the, we're dividing two powers with the same base, we subtract the exponents. Okay. What did we do? We subtracted the exponents. We took 5 minus 3 is equal to 2. So let's write these as logs. This is the log of 1, 2, 3, 4, 5. Log of 100,000 minus the log of 1,000 is equal to the log of 100. Okay, remember the log of 100,000. That's 10 to the what gives you 100,000. So this thing's just equal to 5. Sometimes it's easier to look at as a power. Log of 10 to the 5th. Since this base matches this base, the log of 10 to the 5th is just 5 minus the log of 10 cubed equals the log of 10 squared. Okay, so we combined these two logs into a single log by dividing the arguments. 10 to the 5th divided by 10 to the 3rd gave you the 10 squared. Okay, so that's how this and this work together. Okay, now let's do the final one, and then we'll try some examples. So yes, this entire page was to fit into those 4 boxes. So better to do this on another sheet of paper. And I'm going to I'll scan this in with the video and the video notes so you can, if you didn't catch anything on here, I'll scan this in for you. Okay, so let's go to the last one, which was log of the power. And this one's actually kind of the easiest one to see. Log of a power. Okay, so when we talk about the exponential rule and then the log rule. The exponential rule, Power of a power is something like b to the x raised to the y. You multiply the exponents, b to the xy. Okay, that's algebraically. And then verbally, you would say when taking the power of another power, you multiply the exponents. Okay, now when you have a log, this is the log of a power. Okay, so algebraically, we would say the log of a power, let's say log base b, of x to the n. Now this one seems less intuitive at first glance, is equal to n times the log base b of x. So basically, when taking the log of a power, you can take the exponent on your power and move that to the front and make it a coefficient of your log. Okay, and here we're actually expanding, going left to right. We're condensing, going from right to left, because this is a single log, and we're turning it into a single log multiplied by a constant. And let's write this out verbally. Okay, so when taking the log of a power, you can move the exponent from your power to become the coefficient of the log. Okay. So now why can you do this? Let's just talk about kind of a simple example. Let's say I've got log of x cubed, and this rule says I can take that 3 and pull it out front. Call it 3 times the log of x. Okay, can I do that? Let's think about this. What is 3 times the log of x? Okay, well, that's the log of x plus a log of x plus a log of x. I've got 3 log of x's, so I can call it 3 log of x's. So now what we're going to do is we're going to apply the product rule. Okay. So if I'm adding 2 logs, let's just first combine these two. When I add 2 logs, I can add them. Now notice my base could have been a base of b, but here they're just base 10 because I didn't state a base. So this would be combining these two alone. I would combine it into a single log, leave the base 10, and then multiply the 2 arguments. That would be log of x squared. Now when I add these 2 logs together, I'm going to multiply the arguments. Log of x cubed. And that's what we have over here. Log of x cubed. Okay? So it just kind of makes sense. If I've got 3 logs, that means I'm adding 3 logs together. And when you condense this, then you get the log of x cubed. So this rule kind of makes sense. Okay? Now let's go to your packet, and we're going to do some examples of these, do some examples together. Okay? So let's look at our packet. We're going to look at the bottom of the packet, and we're going to, this is an interesting type of problem. So let a equals log of 3, b equals log of 4, and c equals log of 5. You use the properties of logs to express each value in terms of constants or the above logarithms, a, b, and c. Do not use a calculator. Okay, so we want to break down log of 12 into things that look like log of 3, log of 4, or log of 5. Okay, well, 12, we can break down 12 into log of 3 times 4 Okay, so that would be log of 3 plus log of 4 if I were to condense. I'm sorry, expand, not condense. And that breaks down even further, log of 3 plus, well, 4 is just log of 2 times 2. So we can break that down into log of 2 plus log of 2. Okay, we've broken it down into, oh, we don't even want to go that far. Sorry. Log of 3 and log of 4. We're just breaking it down to log 3 and log 4. So log 3, well, that's A, plus log 4, that's B, and we're done. That's as far as we have to go. We want to break it down so that in terms of either constants or things that aren't logs, and then these 3 variables. Okay. So this one, there's a couple ways we can do this. Let's use the log of a power. Okay, so this is the log of 16, but 16 can be written as 4 squared. That 2 can come out front. So 2 times the log of 4. And the log of 4 is b, so we can call this 2b. And this one, log of a quotient, so we can call it log of 3 minus log of 5. And log of 3 is a, minus log of 5 is c. And log of 75, so I'm going to call that log of 25 times 3, or 5 times 5 times 3, 25 times 3 if I break down 75. So that's going to be log of 5 plus log of 5 plus log of 3. So log of 5 is c, so c plus another c plus log of 3 is a, so that's 2c plus a. Log of 50, we can call that log of 5 times 10, or 5 times 5 times 2. That's going to be log of 5 plus log of 5 plus log of 2. So c plus, oh, we don't have a 2 there, do we? Oh, here's a tricky one. Watch this. So we could call this log of, let's just do 5 times 10. So then that's log of 5 plus log of 10. Log of 5 is c. Log of 10, log of 10 is just 1. Remember that your base is 10, so this means what's the exponent you put on a 10 to get 10? So that's just 1. Okay. This one's going to be a little tricky also. So let's do, this is the log of 0.8. So let's write that as a fraction. 0.8 is 8/10 or 4/5. So that's going to be log, that's a log of a quotient. So log of top minus the log of the bottom. Log 4 minus log 5. So that's going to give you log of 4 is b minus log of 5 is c. Okay, and let's look at the next page. I don't think I need to go through all of these with you, but, and if you understand, it's fine. Feel free to turn off the video and go ahead and get started with working through all these. I'll work through a couple of them together. So if you're still stuck, you still feel like you need a little bit of guidance, I'll do a few more. Okay, write each logarithm expression as a single log. So we're taking multiple logs and we're condensing. Okay, down here at the bottom, we're going to expand. So I'll do a few from the top and a few from the bottom. So here, the first one, log base 5 of 4 plus log base 5 of 3. The bases are the same, and we're adding 2 logs, so we can multiply the arguments together. 4 times 3 gives you 12. Okay. Let's look at 3. 2 log of x minus 3 log of y. Okay, now you cannot subtract these when you've got a coefficient in front. You have to deal with the coefficient first. So this coefficient, if we use the power rule in reverse, this is equal to log of x squared, then minus log of, same way, this 3 is going to get popped up here as an exponent on the y, log of y cubed. You want to combine these into a single log. So when you combine them into a single log, that also assumes you cannot have a coefficient in the front. So that's another reason. You have to take care of that coefficient first. Now we're subtracting 2 logs. The bases are the same. They both have a base of 10. So this is going to be log of x squared over y cubed. Okay. And what else? I want to look at 4, because this one's a little weird. You've got log of a power. So you're actually condensing into a single log, but this thing goes up here. Now, since this thing is a coefficient of the entire log, it has to be an exponent on the entire argument. So log of 3x to the 1/3 plus log of 3x to the 2/3. Okay, because this coefficient gets bumped up there on the argument also. So now when we add these two, log of, and we're going to multiply the arguments. So we get 3x to the 1/3 times 3x to the 2/3. The bases are the same, so we can add the exponents. Go up here, log. Our base is 10. So log of 3x, add the exponents. So 3x, 1/3 plus 2/3 is 3/3. So we just get log of 3x. Okay, number 6 down here. Now this would have to be, you cannot, it's not 1/3 times the log of something. There's no way to move this as an exponent on the argument. So we first have to distribute this to each of these terms. So 1/3 log base 2 of x minus 1/3 log base 2 of y. Now we bump that up top. Log base 2 of x to the 1/3 minus log base 2 of y to the 1/3. Now let's combine those. We're subtracting logs, so we divide the arguments or the powers. So x to the 1/3 divided by y to the 1/3. Okay. Since they're both 1/3, we could say log of x over y to the 1/3. It might have been easier to just simplify inside of here first. Call that log base 2 of x over y, then you can pop that as an exponent. You get the same answer. That might have been a little quicker. Okay, same thing. You can work through those next ones, and I will have the answer. When I post this, they will be all filled out. Let's do some of these where we're expanding. Okay, so when you expand, make sure you use the rules in the proper order. Now this 4, you can't pull that out front because it's not an exponent on the entire argument. It's only an exponent on the z. This 4 has nothing to do with the x and the y. So if you move it in front, now it's being multiplied by the entire log. It is going to affect the x and the y. So think about, you've got to break these apart first. So log of x plus log of y plus the log of z to the 4th. Now you can pull that, but just in front of this one. So that 4, since it's just on the z, it's only going to affect the log of the z. So log of x plus log of y plus 4 log of z. Now that's fully expanded. Okay. This one, you can't do the product rule first because it's not the log of a product. It's the log of a quotient first, because you've got something divided by something. You have to break the quotient apart first before you can dig into the product that's just in the numerator or the product that's just in the denominator. So that's going to be the log of the numerator, 5x, minus the log of the denominator, 4y. Now we can break that apart. Log of 5 plus log of x. Now be careful here. You're subtracting this entire log, so when we break this apart, this negative has to distribute to all the parts. So that's going to be log of 4 plus the log of y. Now distribute that negative. We get log of 5 plus log of x minus log of 4 minus log of y. And really, if we want to fully expand, oops, you can't see that. This is really the log of 2 squared. So that actually needs one more step. Log of 5 plus log of x minus, and that's going to be 2 log of 2. So that's like the log of 2 squared. The exponent comes out front, minus the log of y. Okay. This next one, this can be tricky. You've got the entire thing under a square root. So let's write that as a power. Log of 2rst over 5w. The entire thing is in a square root, so the entire thing is raised to the 1/2. That 1/2 can come out front. So I've got 1/2 times the log of 2rst over 5w. Okay, which is equal to 1/2, and that's multiplied by the entire thing. So let's do the log of the top minus log of the bottom. Log of 2rst minus log of 5w. Okay, let's break these apart. 1/2 times, that's going to be log of 2 plus log of r plus log of s plus log of t minus, let's do log of 5. Really, if we broke this apart, that's log 5 plus log w, but you're subtracting the entire thing. That negative has to distribute to both. Log of w, and now let's distribute the 1/2. So we've got 1/2 log of 2 plus 1/2 log of r plus 1/2 log of 5 plus 1/2 log of t minus 1/2 log of 5 minus 1/2 log of w. Okay. And let's see, I'll leave you to work on that one. Let's see, anything on the next page? Actually, yeah, let's do maybe 1 or 2 on the next page. Here we're solving equations, and the way you're going to solve your equations is by using the rules of logs. Okay, this first one is a straightforward rule. If you have log base 8 of something equal to log base 8 of something else, as long as these bases are the same and it's a single log on the left, single log on the right, the only way these can be equal is if the arguments are equal. So you can set their arguments equal. Now be careful. You're not dividing both sides by log base 8. That doesn't make any sense. You divide both sides by something when they're being multiplied. This does not mean log base 8 times this. This is an operator. It's log base 8 of this. But you are saying that if you have log base 8 of something equal to log base 8 of something else, you can set those arguments equal, because this means 8 to the something equals x plus 1. Well, 8 to what equals this? And if those two exponents are equal, then their powers must be equal. Okay? Remember, this thing is the power. This thing means 8 to the something. This thing means 8 to the something. So we can set these equal, subtract x from both sides, add the 2, we get 3 equals x. And you do need to double check, plug it back in, and make sure it doesn't make any of your arguments negative. 3 works here, 3 plus 1 is fine, 4 is positive. 2 times 3 is 6, 6 minus 2 is 4, that's positive. Remember that you cannot take a log of a negative number. So if you ended up with a negative, it is possible for this to be an extraneous solution. Okay. See if maybe that happens over here. Log base 7 of something equals log base 7 of something else. We can set the arguments equal. 6x plus 4 equals negative 3x minus 5. Add that over there. We've got 9x equals, subtract that over there, equals negative 9. X equals negative 1. Now that doesn't necessarily mean this is extraneous. We just have to double check. Does this make either of our arguments negative? Plugging in negative 1 here, 6 times negative 1, that's negative 6 plus 4. Uh-oh, that's a problem. So this is extraneous. So we would say no solution. We don't even have to check over here. We could also check. Negative 3 times negative 1 gives you positive 3. Positive 3 minus 5 gives you negative 2. So this would have been a problem also. Okay. Now let's go down here, number 15. Log base 2 of x plus log base 2 of x minus 4 equals 5. Okay, now there's no way to solve this when these are separate logs, but we can add these logs together by multiplying the arguments. We're going to use the log of a product property. So this is log base 2 of x times x minus 4 equal to 5. Okay? Now we've got a simple log statement. A log statement on one side, a constant on the other. Okay? We can turn this into an exponential function. Remember, log base 2 of this thing equals 5 means we can start with the base. 2 raised to the 5th is equal to this. 2 raised to the 5th is equal to x times x minus 4. So 32 is equal to x squared minus 4x. So 0 equals x squared minus 4x minus 32. You can use the quadratic formula, or let's see if that factors. Two numbers that multiply to negative 32 and add to negative 4. 8 times 4. Okay, that works. Minus 8x plus 4x gives you minus 4x minus 32. So x is either equal to negative 4 or positive 8. Now we have to double check that these work. The negative 4, if we plug it in here, well, that's a problem. Okay, so we can cross that one out. Plug in 8 here. Log base 2 of 8 is fine. 8 here, 8 minus 4 is 4. That's fine. So our answer is x equals 8. Okay. If you understand these, you can stop the video, continue, but I think I'm going to work through the rest of these real quick, just so in case anybody wants to see how to do them. Okay, so these two, I'm going to add these two logs together by multiplying the arguments. So that's going to be 3x plus 1 times x minus 1 equals 2. So that's 8 squared. 8 raised to the second equals this. So 64 equals 3x plus 1, x minus 1. Okay, let's multiply that out. 3x squared minus 3x plus 1x, so minus 2x minus 1 is 64. So 0 equals 3x squared minus 2x minus 65. Oh, brother, do we think that's going to factor? Let's try it. So this would have to be a 3x. This would have to be a 1x. And what multiplies to 65? 13 times 5. Should we try that? 13 and 5. Remember, we can't really worry about this yet because the outers and the inners have to add up to that. So the outers multiply to 15, the inners multiply to 13. So if we have negative 15 and plus 13, that actually works, doesn't it? 3x squared minus 15x plus 13x gives you minus 2x minus 65. Okay, so we can set this thing equal to 0 and this thing equal to 0. Here we get x equals 5. Here we get 3x plus 13 equal to 0. So x would equal negative 13 over 3. Let's just see if any of these make any of the arguments negative. The 5, 3 times 5 plus 1, that's positive. 5 minus 1, that's positive. Negative 13 thirds. 3 times negative 13 thirds is going to be negative 13. Plus 1, that's not enough to make it positive. So our answer is just going to be x equals 5. Okay, let's go to the next one. Here we've got logs on both sides of the equation. Okay, so we're not going to have to do this thing. We've got base raised to an exponent equals this. Let's just get a log on the left side and a log on the right side. So we're basically condensing the left, condensing the right. So this is going to be log base b of x squared. Notice that 2. I use the log of a power rule equals. Now these don't have coefficients, so I can simply, and the bases are the same, log base b of 2 times 2x minus 2. Now I've got log of something equals log of something else. So x squared has to equal 2 times 2x minus 2. And solve, x squared equals 4x minus 4. X squared minus 4x plus 4 equals 0. And I've got, sorry, so x minus 2 quantity squared, 0. So x must equal 2. Just double check that that works out. That's fine. That's fine. 2 times 2 is 4 minus 2, so that works. And then the last one. So we have to combine this into a single log, and that's already a single log. So that's going to be log base 3 of x squared plus log base 3 of 5 equals log base 3 of 14 plus 3x. Combine these into a single log, log base 3 of 5x squared equals log base 3 of 14 plus 3x. Single log, the bases are the same, so we can set the arguments equal. 5x squared equals 14 plus 3x. So we've got 5x squared minus 3x minus 14 equal to 0. Oh, dare we try factoring? Let's try it. It would have to be 5x and x, because those are the only factors. These two multiply to 14. So either 1 and 14 or 2 and 7. Let's see if we do a 2 here and a 7 here. That doesn't work. Let's try this. 2 and a 7. That would give us 10x and 7. Oh, that does work. Okay, so the outers give us 10x. The inners give us 3x. So that give us 7x. That's a difference of 3. So that would have to be minus. That would have to be plus. It's a little trial and error. Okay. So let's double check. 5x squared minus 10x plus 7x is minus 3x, and then minus 14. So here you've got 5x plus 7 equals 0. 5x equals negative 7. So x equals negative 7 fifths. And here we just get 2. Okay, let's plug them in, see if it works. It's a comma, not a 12. So negative 7 fifths. Oh, that's a problem right away, because that makes this argument negative. The 2 is fine there. 2 is fine there. So x equals 2. All right, and that's all for now. I know that was long. Hope that was helpful.